Hello everyone and welcome to the next video of determinants. Today we will learn how to find adjoint of a matrix of a 2 by 2 and a 3 by 3 matrix, and also we will learn how to find the inverse of a matrix with the help of adjoint. We will also learn some theorems and facts about the uh, determinant chapter using this adjoint and inverse. Let's talk about the first topic, that is adjoint. The adjoint of a square matrix capital A is equal to Aij, whose order is m by n, is defined as the transpose of the matrix of capital Aij. If you remember what is capital Aij is the cofactor of the element Aij. So when we write cofactor, so adjoint of A is transpose. Transpose means आप क्या करोगे, इसको फर्स्ट रो के कोफैक्टर्स को यू विल राइट इट इन द फर्स्ट कॉलम, सेकंड रो के कोफैक्टर्स यू विल राइट डाउन इन द सेकंड कॉलम, एंड थर्ड रो के कोफैक्टर्स यू विल राइट डाउन इन द third column. This is what is known as the adjoint. Symbol is ADJ of capital A. If you remember, for a square matrix, if I want to find the cofactor of A11, you will forget the row and forget the column. This will be the cofactor. Similarly, A12, forget the row, forget the column. This will be the cofactor, but with a minus sign. Similarly, for this, forget the row and the column. This will be the cofactor, but with a negative sign. And for A22, forget the row, forget the column, A11. So there is a shortcut to finding the adjoint of A. You just interchange the diagonal elements, यानी कि A22 इधर आ गया, A11 को इधर लिख दिया, and you change the sign of the non-diagonal elements. That is A12 इधर ही रहा with a minus sign, and A21 भी इधर ही रहा with a minus sign. That is the shortcut of adjoint of A. But I'm sorry to say there is no shortcut for a 3 by 3 determinant. So you have to find the matrix, adjoint of a matrix of a 3 by 3 matrix using your normal method. That is, you have to find all the 9 cofactors and you have to transpose the cofactors. Okay, children? Let's move ahead. Theorem 1 says if A be any square matrix of order n, then capital A, bracket open, adjoint of A equals to capital A into adjoint of A is equal to adjoint of A into capital A is equal to determinant of A into I. Okay, where I is the identity matrix. Let's do the verification. Check करो, capital A ये है, adjoint of A इसके cofactors हैं, right, with a ट्रांसपोज. तो चेक करो, मैंने जब कोफैक्टर्स लिखे तो मैंने इसका कोफैक्टर यहाँ लिखा है, लेकिन A12 का कोफैक्टर यहाँ लिखा है, यानी कि मैंने ट्रांसपोज पहले ही कर दिया है. A13 का जो कोफैक्टर है वो मैंने यहाँ लिखा है, राइट. So this is how I found out the adjoint. Now when you do the multiplication, children, let me just show you the first row. If I want to find the multiplication, I want to do A into adjoint of A. So obviously multiplication का rule है, ये 3 by 3 है, ये भी 3 by 3 है, right? So this and this has to match, और जो मेरा आंसर आएगा वो भी कोई 3 by 3 matrix ही आएगा. Now suppose I have to write this position, right? So how will I write? So can I say this position will be first row into first column, children? So that is A11 into capital A11 plus A12 into capital A12 plus A13 into capital A13. So don't you think, if you remember very clearly, in the last exercise we studied, this is what is determinant of A is. So first position पे मेरा determinant of A आ गया. For the second position, let's try. This is this first row into second column, यानी कि A11 into capital A21 plus A12 into capital A22 plus A13 into capital A23. अगर मैं A12 पुट करूँ, A12 का मतलब क्या हुआ, चेक करो. A12 का मतलब हुआ कोफैक्टर ऑफ द सेकेंड रो फर्स्ट कॉलम. सो सेकेंड रो फर्स्ट कॉलम का कोफैक्टर क्या हुआ, फॉरगेट द रो, फॉरगेट द कॉलम, एंड इसको आप 2 by 2 डिटर्मिनेंट की फॉर्म में लिखोगे राइट, और माइनस का साइन डालोगे, यानी कि क्या आएगा, forget the row and the column, so A12 A33 minus A32 into A13. Similarly, when you will open this, A22 लिखोगे, forget the row and the column, so A11 into A11 A33 minus A31 into A13 प्लस A13 इंटू A23 का लिखना है कोफैक्टर, तो अगेन फॉरगेट द रो फॉरगेट द कॉलम, माइनस साइन आएगा, राइट, 2 + 3 एक ऑड नंबर है, फॉरगेट द रो एंड फॉरगेट द कॉलम, तो क्या आएगा, A11 A32 माइनस A31 इंटू A12. जब आप इसे ओपन करोगे चिल्ड्रन, everything will get cancel and you will get 0. Similarly, when you will open for all, you will get 0 0 at all the position except the diagonal elements you will get as determinant of A, and rest all positions you will get 0. Now when you will take determinant, this is a matrix children, so इसमें से determinant of A common आ सकता है, right, and this is I. So I can say A into adjoint of A is equal to determinant of A into I. So this is how we get our proof. So also it can be proved other way around also, कि आप adjoint of A into A करोगे, adjoint of A into A करोगे तो वो भी आपका determinant of A into I ही आएगा, right? This is how you prove the theorem 1. Alright, let's move ahead. You should know what is a singular matrix. A singular matrix एक ऐसा square matrix होता है जिसका determinant 0 होता है, और अगर किसी का determinant 0 नहीं है तो उसे बोला जाता है नॉन सिंगुलर मैट्रिक्स, सिंगुलर मैट्रिक्स का ऑपोजिट. इसमें 1 मार्कर हॉट्स क्वेश्चन आ जाते हैं कि जिसमें वो क्या करते हैं, ऐसे कुछ ऐसा दे देते हैं, determinant of A x2 1 and 0, and they say it is a singular matrix, find the value of x. So if it is a singular matrix, you know that determinant of A will be 0 and it will be, here it should not be 0, so 10, maybe 10 है यहाँ पे suppose. So 10 into x minus 1 into 2 is equal to 0. So x is equal to 2 by 10, that is 1 by 5. So this kind of a 1 marker question can come. Okay, so you should always remember what is determinant of A. If A and B are non-singular matrices of same order, non-singular means ये zero नहीं है, इनका determinant non-zero है, of same order, then AB and BA are also non-singular matrix of the same order. मतलब अगर A भी zero नहीं है, A का भी determinant zero नहीं है, और B का भी determinant zero नहीं है, so A और B का भी जो determinant होगा वो zero नहीं होगा, it will be a non-zero identity. Okay, or maybe and BA भी नहीं होगा, BA, determinant of BA will also be non-zero, right children? So this is what is your theorem 2. This is just a mathematical proof, so there is no need, you should just know the fact. Similarly, अगर आपको determinant of AB खोलना है तो it can be written as determinant of A into determinant of B. This also you should know, that the determinant of product of the matrices is equal to the product of their respective determinants. That is, determinant of A into B is equal to determinant of A into determinant of B, where they both are of same order. Let's move ahead. It is again a very very important 1 marker question कि अगर आप, ये तो हमने पिछला फर्स्ट स्लाइड में ही सीखा था, adjoint of A into A is determinant of A into I, right children? ये तो सपोज करिए अगर मैं दोनों तरफ डिटर्मिनेंट फाइंड करती हूँ, तो इसका भी डिटर्मिनेंट फाइंड करती हूँ, तो मैट्रिक्स डिटर्मिनेंट में कन्वर्ट हो गया, और डिटर्मिनेंट में से जब कॉमन आता है तो वो रो वाइज कॉमन आता है, यानी कि इससे डिटर्मिनेंट ऑफ ए कितनी बार कॉमन आएगा, रो 1 में से, रो 2 में से, रो 3 में से, यानी कि डिटर्मिनेंट ऑफ ए रेज टू पावर 3 कॉमन आ जाएगा. So if I want to simplify this, and ये हम ऑलरेडी सीख ही चुके थे कि ए बी का जो डिटर्मिनेंट है वो ए का डिटर्मिनेंट अलग और बी का डिटर्मिनेंट अलग होता है. So this can be split into 2 parts, determinant of adjoint of A into determinant of A, using this theorem, right? So check here children, this is I. Anything into I is the number itself. So I can say adjoint of A का determinant into determinant of A is determinant of A का whole cube. So ये और ये cancel हो जाएगा, यहाँ पे whole square आ जाएगा. So in general I get another formula that if A is a square matrix of order n, then determinant of adjoint of A is equal to determinant of A raised to power n minus 1. So again इसमें कैसे question आते हैं वो दे देते हैं. Again a 1 marker HOTS question क्या आता है? They tell you that determinant of A is 2 for a 3 by 3 matrix. Okay, then you have to find adjoint of A. This is your question. So how will you do it? We know the relation that adjoint of A children is determinant of A raised to power n minus 1. So it is यहाँ पे 2 power n क्या है 3 है minus 1. So 2 to the power 2. So what will be your answer? 4 will be your answer. Or your question can be given other way round also, that adjoint of A is equal to suppose 64, okay, and for a 3 by 3 square matrix, and you have to find determinant of A. So again same formula can be used. If I put it here, so 64 is equal to adjoint of A, determinant of A raised to power n minus 1 यानी कि 2. So अगर मुझे ये 2 हटाना है तो वहाँ square root हो जाएगी. So can I say determinant of A is under root of 64? So you know what is under root of 64. So plus minus 8 is your answer. So these are the two kinds of HOTS question, basically 3 HOTS question which I've taught you in this video. For the exercise, we will continue. Okay children, I will do lots of questions, but let's talk about what do you mean by a invertible matrix, the last concept of the video. A square matrix A is invertible if and only if A is a non-singular matrix. यानी कि invertible matrix के लिए जो A है वो non-singular होना ज़रूरी है. Non-singular means determinant of A जो है वो 0 नहीं हो सकता. So let's talk about. You know what is a inverse matrix. ये तो हमें पता ही है कि inverse कैसे find करते हैं. ये हमने last chapter में matrix में सीखा था. अगर A into B is equal हो B into A के is equal to I के, तो A B का inverse है and B A का inverse है. Right children, this is the statement which we have already learned. Now let's apply the same statement. A into B is equal to I. So if I take both side determinant, you know again I can open this. Determinant of A into B can be written as determinant of A into determinant of B, and determinant of I. Determinant of I is what? 1. I तो एक 1 की तरह act करता है, is 1. Right? So hence अगर it gives that determinant of A is not equal to 0, क्योंकि दो नंबर को मल्टीप्लाई करके अगर 1 आएगा तो ऑब्वियस है ना कि वो नंबर 0 नहीं हो सकता. तो इसका मतलब जो A है वो हमेशा क्या होगा? नॉन सिंगुलर होगा इस केस में जहाँ पे A इंटू बी जो है वो I है. राइट. कन्वर्सली अगर आपको उल्टा प्रूफ करना है, क्योंकि इफ एंड ओनली इफ था, तो कन्वर्सली लेट A बी अ नॉन सिंगुलर मैट्रिक्स, यानी कि डिटर्मिनेंट ऑफ A जो है वो नॉट इक्वल टू 0 है. तो अगेन हमें ये स्टेटमेंट पता है, A इंटू एडजॉइंट ऑफ A इज इक्वल टू एडजॉइंट ऑफ A इंटू A इज इक्वल टू डिटर्मिनेंट ऑफ A इंटू I. So if I take this determinant of A that side, so can I say A into 1 upon determinant of A into adjoint of A, or 1 upon determinant of A into adjoint of A into A is equal to I. So check here. If I compare this with this equation children, can I say this is B? A into B is equal to B into A is equal to I. So this becomes my B. So what is B? B was inverse of A, right? यही definition थी ना. अगर A into B equal होती है B into A equal to I, so B is known as A inverse. So A inverse is B, which is A inverse is 1 upon determinant of A into adjoint of A. So this is your another formula to find inverse. ठीक है? So we will continue. I will continue in the next video. and I will teach you application of all this using a exercise, NCERT exercise. If you have any doubt regarding invertible matrices or regarding how to find adjoint of A, kindly mention in the comment below.